Hi, I'm Seminole County Sheriff Dennis Lima. All of the science that you're about to see, as well as our highly trained expert team, are part of one common goal here at the Seminole County Sheriff's Office: the search for justice.
The Evidence Unit is a fundamental part of the Forensics Laboratory Services Division. It receives, preserves, and safeguards all found, recovered, and evidentiary property for the Seminole County Sheriff's Office. It currently manages over 100,000 items while they're being processed in one of our laboratories. Here in the Biology Pre-Screening Lab, analysts focus on physical evidence for the presence of DNA, such as bodily fluids. To search for these valuable sources of evidence, analysts use forensic light to gather the evidence they need. Once the most useful samples are identified, they go to the Florida Department of Law Enforcement or a private lab for further DNA testing. In order to conduct this careful and delicate work, analysts train in evidence recognition, patterns of fluorescent light, and testing methods, all done here with our biological pre-screening laboratory. In the latent print unit, analysts spend years in training to help them conduct examination of both latent and ridge impressions. Characteristics of so-called friction ridge skin can be transferred to a surface when an individual touches an object, creating a so-called latent print. It could also be made using traditional fingerprinting techniques known as inked prints. Analysts are trained to use imaging technology to figure out which characteristics of prints could be used for comparison. Analysts can compare these latent and inked prints to known individuals and can digitally encode them to search state and national databases for potential matches. Analysts gather the information to arrive at a conclusion on the source of the prints. The latent print unit focuses on the smallest details, which could lead detectives to big breakthroughs. This room houses our new superglue chamber. The compound we use is a more forensic superglue than what's usually found in homes. Our analysts put a few drops of superglue into a tray, and by introducing heat with hot plates in each chamber, we then vaporize it. We also have humidifiers to add moisture to the air. Why do we do that? Because the vapor and moisture flow around the items of evidence we've placed inside. The superglue is attracted to the moisture and other components in latent prints. The superglue attaches to the components present in the prints and solidifies them. The prints become white and visible and can be photographed. More importantly, the prints now visible on the evidence are another potential key building block to making a case. Here in our black powder room, we have fluorescent powders which glow when introduced to our alternate light sources. We also have black and white powders which help us to identify evidence on a variety of different surfaces. We also use magnetic powder while searching for shoe impressions. We have white and black latent print lift cards and tape in various sizes. We also use what we call gel lifters, like a thin rubber mat with one sticky side. We have chemicals to develop latent prints on the sticky side of tape. It's called tape glow, and it lights up to make potentially valuable prints visible. This room also contains SPR, or small particle reagent, to develop latent prints on wet items like concrete, bricks, or even rock. The next part of our laboratory is dedicated to processing both porous and semi-porous evidence like paper, cardboard, fabric, or untreated wood. Around the lab, we call this the ninhydrin room because that's the chemical we use most. Ninhydrin reacts with the fingerprint residue to form a visible purple compound. With this new humidity chamber, we only have to wait 5 minutes. This has drastically increased our efficiency in processing this type of evidence. Ninhydrin also helps identify potentially valuable blood evidence. This is Physical Developer, a silver-based liquid which reacts with fingerprint residue. Physical Developer can be used on both wet and formerly wet items. For the porous items we mentioned, crime lab analysts also have a chemical which reacts with fingerprint residue and will glow when exposed to a forensic light source. Our big chemical laboratory contains plenty of table space for evidence, a camera, chemicals for processing, and a fume hood specifically for suspected drug evidence. We have 3 chemicals our crime lab analysts use on their evidence. All are fluorescent dye stains used to make latent prints more visible on colored surfaces. These stains are used with forensic light to make them glow. Each dye stain glows a different color under forensic light. There are 3 types of light sources: a flashlight, an LED hand scope, and a larger crime scope. We also photograph latent prints here. These examination quality photographs are taken with a scale, which can then be printed to natural size for comparison purposes. It houses a camera on a tripod connected to a computer. Our analysts photograph hundreds of items every year: water bottles, lighters, car parts, money, clothing, anything you can possibly imagine. Here in our impression evidence lab, shoe and tire impressions found at crime scenes provide important investigative leads. They can be 2-dimensional, such as a tire mark on asphalt, or 3-dimensional, like a shoe print left in sand. Both types can be enhanced, documented, and recovered in several ways, some of which include powder and lifting techniques, casting, and photography. And once the impressions have been documented and recovered, they can be compared to known shoe standards. The vast number of shoe and tire tread designs, as well as the quality of the impressions, can make this task long and difficult. Impression analysts have a unique job, and their expertise allows them to identify characteristics in a shoe print for potential evidence. They enhance the prints using physical and chemical processing techniques, creating molds and casts of the shoe impressions at crime scenes, then photographing them before and after processing, and evaluating and comparing the shoe prints. This lab also contains an electrostatic detection apparatus. The ESDA visualizes indented handwriting on paper. These impressions can include handwriting and shoe and tire impressions. In every single step of this process, our analysts use protective gloves, safety goggles, and other precautions because safety is always priority number 1.